Hello champions, welcome to my math class. Today we're going to learn about estimation. So we have estimation. What is estimation? We know in several occasions when we're talking about estimations, you have to, it comes by having a longer number. Maybe let's say you have a number like 3.7897223. So it's very long. And that one will now when you are told to estimate, it means you don't have to mention the actual value of the number. Let's say you say instead of writing that long number, you write 3.1 and then you find. So what happens when you say you estimate a smaller number or you overestimate? So sometimes you might use a smaller number different from the actual number, or you might use a bigger number greater than the actual number. So if you use a smaller number, it means you have underestimated. And if you use a bigger number more than the actual number given, it means you have overestimated. Now, what happens when you use these two? What happens when you're supposed now to either divide these two numbers? Maybe one you have overestimated and one you have underestimated. What do you get? So there are those kind of equations that you need to compute and then be able to find an evidence in particular time. But now, the first thing that we need to know is estimation. We say it's using of an approximate value for a calculation rather than actual answer. So you're using an approximate value for calculation rather than the actual answer. And then you can say you can only estimate numbers by rounding them up to the nearest digit value. Yeah, sometimes you're told to maybe round off to the nearest digit value, let's say nearest tens, hundreds, thousands, if it's that case. But in most cases, we say we can round numbers given to the significant figures. In most cases, we use these significant figures now to either underestimate or overestimate. Now, for instance, rounding of numbers, let's say you're given the actual number is, let's say, the actual number is 7. The actual number is 7.8. The actual number is 7.8, and then through 7.8, now we need. Okay, the actual number is 7.8, and then you say, okay, what will be this number if we round it off to one significant figure? Obviously, it will be 8 because this number is greater than 5, and it add ones into the other digit, and the rest turns into 0. You have 8, and if you have 18, let's say you have 18. We have 18, correct? And then this 18 we are supposed to round off to maybe to the nearest one significant figure. Obviously, it will be 20 because 8 is greater than 5. And then we have, let's say we have 3.65 times 10 power negative 4. Now, in this case, and then we are told to in this case, you are told to round off to one significant figure. Obviously, when you're rounding off to one significant figure, it will be 4 times 10 power negative 4. And you can see that. And then maybe you have, we have 1080, and then you're told to round off to one significant figure. Obviously, our answer will be 1000. So we have these cases to 8, we have 8, 20, 4 times 10 power negative 4, we have 1000. And all these ones is, you can see there are some numbers they were bigger, and then when you are rounding to one significant figure, you got a smaller number. But there are some numbers they were smaller, but when you they were bigger also. When you round off to a significant figure, it became smaller. And you can look, there was a number that was 18, but rounding off to one significant figure, you got 20, which is higher number. So this one can even affect a specific value. So the next question is, how do I know if I have underestimated or overestimated? So you can know if you have overestimated by rounding up. Yeah, you can know if you have estimated by rounding up. The question is, how do I know if I have underestimated or overestimated? I've said you can know if you have overestimated by rounding up. When you round up, that means, for example, you had a smaller number. A number is 19, and then rounding up, you got from 19 you get 20. You know, okay, this is overestimated. And then you can know if you have underestimated by rounding down. For instance, you have a number let's say you have 24. So the actual number is 24. But when you round it off to one significant figure, it will be 20. So you see, this one was bigger, and now it becomes lower value. This one was small, it becomes big. You get that? So you can see this is small value. So this was small, it becomes big, but this was big, it became small. So in this case, this scenario we'll say underestimated. And in this scenario, we say overestimated. So in this case, we say this is overestimated. In this scenario, we say this one I've underestimated. So we'll go to some specific examples. Maybe we can do. Let's say you're given we might be given a question. Calculate an estimate for 17.3 times 3.81 divided by 11.5. State with a reason whether the estimate is an overestimate or underestimate. Okay, correct. So example. We're going to the example. In the example question, it says 17.3 times 3.81 over 11.5. So we say 11.5. Correct. So 11.5. Now we're given this. So say calculate an estimate for 17.3 times 3.81 divided by 11.5. State with a reason whether the estimate is an overestimate or an underestimate. So if you are going to convert each number, let's start with the numerator. We know numerator is the top number. Numerator is the top number in a fraction. So we have 17.3. If we round off to one significant figure, 17.3, obviously we'll consider this digit here in the ones. It's higher than 5. The answer will be okay. So the answer will be 20, and then to one significant figure, and then 3.81 estimate to one significant figure, it will be 4, and then 11.5 in denominator, whereby it's denominator. 11.5 will be 10. Now, when we divide this in that scenario, when we divide it, 20 multiply 20 times 4 over 10. 20 times 4 is 8. Divide by 10, you get 8. So you get so you can see on top, you will say in this case, if you look, even with if you predict, you will obviously understand that even if you predict, you will obviously understand that the number that were on in the numerator, they were smaller. 17.3 became 20 and 3.81 became 4. Therefore, you have bigger number divide by a smaller number. Obviously, your answer will be and it will exceed the actual calculation. You are to use the actual numbers given. Therefore, you say this is an overestimate as the numerator was rounded up and the numerator was rounded down. Majority of the questions we were able to do, especially the one that they were looking for overestimate, underestimate. So I'll also go and do something else called number or bound. So we know I've already explained about that one. So I'm also going to teach you bounds. So we're going to talk about bounds. Bounds, we say, and error intervals. So this is still is also one of the units, subunit in number system. And it's talking about, so we say bounds. What are bounds? Bounds. We can say bounds. We say bounds are values that rounded numbers can lie between. And then we say smallest value that a number can take is the lower bound. The smallest value that a number can take is called the lower bound. And the largest value that a number must be less than is called the upper bound. We say the largest value that a number must be less than is the upper bound. Right, correct. So we say lower bound is less than or equal to x, and upper bound, we say x is less than the upper bound. Yes, this is what is being represented with our number there. So how do we find the upper bound and the lower bound for rounded number? Correct. This is also something that we need to know. how do we find the upper bound and the lower bound for rounded numbers? We say identify the degree of accuracy to which the number has been rounded. That's rule number 1. Then identify the degree of accuracy to which the rounded number has been rounded. Then divide the degree of accuracy by 2. Add this value to the number to find the upper bound. Subtract this value from the number to find the lower bound. The error intervals is the range between the upper and lower bound. So we say error intervals will be given, obviously. So this one say how do we find, like for finding. So I'll help to do a couple of questions so that we might understand what we're talking about when we're trying to talk about upper bound and lower bound. Yeah, what exactly I'm talking about. Let's say, for instance, we have a number. Let's say we are given a number. Say we are given 36,000. Let's say I'm given 34,800. This is a number. Then we say identify the degree of accuracy to which the number has been rounded. So for example, we say example 34,800 has been rounded correct to the nearest. So if you say if this is our answer, 34,800 has been rounded to the nearest 100. Divide, so say, okay, so to the nearest 100. So what do? We say divide the degree of accuracy by 2. So what we'll do, this is the number. We say this is the number after it has been rounded. It's 34,800 has been rounded to the nearest 100. So what do? We say the rule, if you want to find the lower bound, we will take the degree of accuracy divided by 2. So the degree of accuracy, we have been told it's here, it's nearest 100. So we take 100 divided by 2 and get 50. Correct. Therefore, after we get that, we say, so adding this limit, what we call limit, to the number that has been rounded, we get the upper bound. Yeah, that's what you get. So for example, in that case, 34,800 add 50, you get 34,850. Correct. And then if you take this number and then subtract it, if you take the limit, which is 50, subtract it with 34,800. So in that case, you have 34,800. So we have 34,800 minus 50. We'll be able to get the lower bound. So you see, in that case, we will say 34,750, which will be the answer. Okay, in that case, we get the lower bound. So the error interval is the range between the upper and the lower bound. So error interval is the range between the upper and the lower bound. So the range. So in that case, you can say now my answers. In that case, you say your answer. Maybe your answer in the middle is 34,800. Then you say it's less than or equal to 34,750. And then this is less than the upper bound, which is 34,850. This is what we say. So the error interval, we say this is obviously the error interval. This will be the lower bound, and this one will be the upper bound. Yeah, and here is the actual number. So that's majority what can be asked in most cases. So I'll do one example to mark the end of the chapter. So we say the length of a rod L is given as, so we have been given here an example. The length of a rod L is given as length is 3.6 kilometer. Correct one decimal place. Find the lowest and upper bound for L. Length is 3.6 kilometer. Therefore, correct. So they say they're only to correct one decimal place. Therefore, we'll take the lowest limit of the number, which will be 0.1. 0.1 because the number has a decimal. So 0.1 divided by 2 will be 0.05. So our limit is 0.05. So when you get our limit at 0.05, to get the upper bound, you add with 0.05. To get the lower bound, you take the actual number minus. So we say the upper bound is equal to 3.6 plus 0.05, which is 3.65 kilometer, but the lower bound is equal to 3.6 minus 0.05, which will be 3.55 kilometer, correct? That's what you do generally. So we know in most cases the calculation that we need to do in finding the lower bound and upper bound of different values, we have to use the same idea. So we can do as much as we can in that category. Like we can do a couple of questions and get the correct answer. Thank you.